Hi everyone, welcome back. Today we are going to deep dive into this interesting research paper. From now on I will be discussing it more frequently. I think maximum amount of knowledge regarding deep learning is stored in these research papers and it's very important to lay emphasis upon these papers. So let's get started. Now we are going to discuss about this paper from Stanford. It's called CheXnet, Radiologist Level Pneumonia Detection on Chest X-rays with Deep Learning. Chest X-rays are currently the best available method for diagnosing pneumonia, playing a crucial role in clinical care and epidemiological studies. Pneumonia is responsible for more than 1 million hospitalizations and 50,000 deaths per year in the US alone. CheXnet is a deep learning model where you feed a chest X-ray image and then it outputs whether the pneumonia is positive or not, along with the heat map localization. It's a 121 deep convolutional network. So you input or feed a chest X-ray image into your 121 layer convolutional neural network and then it outputs whether the person is suffering from pneumonia or not. And it has been able to output results which are more accurate than radiologist. The model has been trained upon chest X-ray 14 dataset which contains 112,120 frontal view chest X-rays. These images contains labeling for 14 different thoracic diseases. They collected the chest X-ray tested of 420 frontal chest X-rays, and annotations were obtained independently from 4 practicing radiologists at Stanford, who were asked to label 14 pathologies even though. And then the performance of individual radiologists by using the majority vote of the other 3 radiologists as ground truth was measured. And now it was evaluated at CheXnet using the majority of 3-4 radiologists provided better results. CheXnet is tested against radiologists on sensitivity, which measures the proportion of positives that are correctly identified as such, and specificity, which measures the proportion of negatives that are correctly identified as such. A single radiologist's performance is represented by an orange marker, while the average is represented by the green. CheXnet outputs the probability of detecting pneumonia in chest X-ray, and the blue curve is generated by varying the thresholds used for the classification boundary. The sensitivity specificity point for each radiologist and for the average lie below the blue curve, signifying that CheXnet is able to detect pneumonia at a level matching or exceeding radiologists. Let's focus upon model architecture. So this task is a binary classification problem since we only require 2 values 0 and 1, which indicates the presence or absence of pneumonia. Binary cross entropy was optimized and a model with the lowest validation loss was selected. Batch normalization has been used. Pretty much every deep learning model includes it as it makes the optimization of deep learning more tractable. Batch normalization has a slight regularization effect as well. Dense connections have been used. DenseNet improve formation and gradients through the network, making the optimization of deep neural networks tractable. Finally, fully connected layer was replaced by the one which has single output, and since it's a binary classification problem, sigmoid nonlinearity was used. Weights of the network were randomly initialized and was trained using Adam optimizer with standard parameters. Beta 1 which was equal to 0.9 and beta 2 was set to 0.999. Size of mini batch was set to 16, initial learning rate was set to 0.01, which was made to decay by a factor of 10 after every epoch. Let me know if you have any queries regarding the content being discussed in this video. Thank you for watching this video and spread the knowledge with your friends regarding these research papers. I'll talk to you next one.